Hello all, I'm Clémentine. So I'm working in the community team at Malt, and I'm here to help coordinate the Malt Academy. So today it will be Rachid who is hosting this session to tell us more about containers. He's gonna introduce himself after. I'm just gonna do a very quick presentation to let everybody arrive on this Zoom. And voilà quoi. So I'm gonna share my screen because I got a presentation for you. So very quickly, what is Malt for new people who are here? Malt is a platform that connects a community of 180,000 freelance to more than 90,000 clients in digital projects. We are based in France, Germany, and Spain. So due to lockdown, we launched 3 major initiatives you have on my screen right now to help every freelancer during this period. So the first one is a page called covid19.malt.fr. It's mostly for French freelancer, so you can find every information about help from the government when you are a freelancer. The hashtag ready to help. So this is only, for people who have a Malt profile. You can add this hashtag to your title in order to show that you are a volunteer for missions to help health services. And the last one is, it's why we are here today. It's the Malt Academy. So you can go to maltacademy.com to have every information. So what is it exactly? It's a peer learning program. We launched just a few days after the lockdown. So the idea is having freelancers who are hosting some academies. So if you want to see every academy, that you can go directly to the website. We are currently looking for new speakers for June and July. So do not hesitate to complete the form on the website. It can be any topics you want, any format you want. And just to let you know, this academy is recording. So if you want to see the replay or to see every replays, you can go as well on this website. So just about how it's working for this session, if you have any questions, you can go directly to the chat of Zoom. I see every people are saying hi and stuff. So you go directly to the chat. You can ask your question to Rachid. We're gonna have them at the same time. He can answer. And voilà, I finished my presentation. Sorry, if you have a question about Malt, I'm gonna put the mail directly, but feel free to contact me at community@malt.com. Voilà, I mute myself and I'll let you enjoy this Malt Academy.
So you should now see my screen. Okay, so thank you all for coming. This is the second time I'm giving this webinar. The first session was in French, and now this session is obviously in English. So the title is Docker Containers Seen by Quick and a Mechanic. To put it simply, what I wanted to try is to explain what containers are using what we do in our day-to-day life, everyday, like making cakes or fixing cars and so on and so forth. Because I'm deeply convinced in the fact that containers are not that complicated to understand and to use. And if we look at what we are used to use in our day-to-day life, we can find similarities between our lives and how a container works, right? So who am I? My name is Rachid Zarouali. So I'm a freelance cloud architect. I've built my own companies. I'm going to speak a little bit about it right after that. I have the chances to be also Microsoft Azure MVP and Docker captains, especially because I'm quite involved in, let's say, containers communities. I'm running my a local community in my city around Docker, around client native ecosystem. So I'm just helping people to get on board, get used to use new techs, new tools, and so on and so forth. In this slide, you have everything you may need to contact me directly, either on Twitter or by email. Feel free to ask if you have any questions. I'll be glad to help anyway. So who's Freelancer? Basically said, this is me. This is just a company that I built for, let's say, the French government, just to have a company that can work with my clients. So this is just me, born in March 2018, actually. It's just the company that I built after more than 20 years spent in IT in different levels and different projects and companies, especially to offer consulting, training, and teaching. So basically said, what I do is I'm helping companies to grow their skills or move their application to the clouds using almost every technology that the cloud-native ecosystems offer. So what you have on the right, explain briefly what I can offer and how, some tools that I use with my clients. I have a lot of clients, not really, let's say few clients. Most of them are either, let's say, food and beverage, Fortune 500, a high security hoster with which I'm working from time to time to help them, let's say, building more skills into their own teams, flight companies, and so on and so forth. Most of the projects that I've been working on are either cloud migrations. So what we do is we take a legacy application or an already existing application that has to move to the clouds, either to a cloud provider or a private cloud in their own data center. So I'm just working with development and infrastructure teams to train them, to look at what we have to use to make this working in the best shape as possible, and so on and so forth. But I'm also working into giving best practices to help companies building their own infrastructure, run their own infrastructure, and so on and so forth. You have the link to my website. There's a lot more information. And again, if you need more information about what I do, what I can offer, then please reach out to me and I'll be more than happy to explain. So before starting about what containers are and how they work, to make it clear, this is clearly an unconventional webinar. I aim to make it the funnier as I can, serious but not too much. And for those who are already familiar with what containers are, don't be afraid. I've made a lot of shortcuts to make this simple to every attendee. And again, if there's any questions, you have the chat, so just drop line in the chat, and in between I'll make some quick posts to see what questions are, and I'll try to answer them as fast as I can. Okay. So the agenda for today, oops, sorry. So the agenda for today is a quick introduction of what containers are in some use cases. We'll speak about what containers, what are the difference between containers and virtual machines, pros and cons, if there's one that you should use in front of the other. Then we'll dig into what containers are exactly, how you can make your own containers and run them into your own machine and your own infrastructure. Then we'll switch to some examples and demos that I have prepared, and we'll finish by opening the area around what microservices are and what are their relation with orchestration systems. So as I said, this is a challenge that I found, and I just wanted to make it simple. I just wanted to see if I can, if I'm able to explain what containers are, if I'm speaking to a cook or to a mechanics, and that's what I really want to try today. And let's see how it goes. So a little bit of history and use cases. So the first point is containers has not been born in 2013. This is a very old technology that has been born in the years, in the 70s, but it got its momentum around 2012, 2013. Before that, we were able to use some software isolation technology, but it was only targeted to high-level system engineers. So definitely not something that you can push to your development teams. And at the same time, in this area, we've seen VMware and the virtualization technologies being born and being widely used. So what happened is, let's say nearly 2012 and 2013, a French company actually named .cloud has been born, and they built their own platform as a service, and they built their own building, shipping, and running systems. And that was let's say the father of what Docker is today. Docker has been made available in 2013 as an open source project. At the same time, Google, for example, was using containers for years, and they have what they called LMCDFI, which is aimed to be, let me container this for you. This was the time where containers were, let's say, being pushed to the public, pushed to the operational people, to developers, and so on and so forth. What Docker and the container nowadays offer is something that is simple to use, and that can be used either if you're a developer, you're in the operational, or in between as a DevOps. That's what Docker offers. This is not a completely new technology that has been born in 2012, as I said. They offered simplicity and the ability to share the same tools between different teams in the same company. So where are we today? 2020 containers are almost everywhere. I mean, we always see them in, of course, clouds. Yes, VMware announced vSphere 7, which has a native and a very deep integration of what container technologies are, especially the Kubernetes orchestration system. But in the year 2020, and containers are really a catalyst of what the DevOps culture is. And what I mean by that is Docker is a perfect tool to make both teams, developers and operational, work together with the same methods, with the same rules, and with the same tools to build an application or application and push them and run them in production safely. We just started to see, you've probably seen that again around the Silverblue project in the Fedora world, which is not the first, but let's say the first real deep integration of containers as a desktop systems. You've seen the WSL2 a few weeks ago in the Windows ecosystem, and we also seen that F16s runs containers. So today, containers are almost everywhere. For next year's 2021 and later on, we start to think about using containers in edges, cars, oven, fridge, watches, and so on and so forth. There are some projects that emerge around how we can use also this technology to our own tablets, to our own smartphone, and so on. There's a bit of making available to the public something that is called unikernel, which is, let's say, to put it simply, the perfect merge of an operating system and an application, both merge in a very single binary. Just if you have any questions, I'll be more than happy to speak a little bit about that, but this is clearly not the subject here. So probably you may have several questions, and I've just grabbed some of them. So why would we have such an overwhelming popularity around containers? For who this technology has been built, and what is its purpose? What are the use cases containers are really useful for? First of all, why? We can simply answer that in the, let's say the, how could I say, the mantra around Docker, which is build, ship, run. And that's exactly what containers offer. The ability to build your package, in our case, a container and image, we'll see that later on, to ship this image anywhere that you can run a container runtime and able to run this application almost everywhere. Build, ship, run. We clearly want to offer, we clearly want to avoid what you've seen here in a very funny way is, I don't care, it works on my machine, I'm a developer, I don't care about the operational. I built the application runs here. It's not my problem, this is just an ops problem. This is also a problem that containers helps in solving. And when I say helps in solving, containers are not solving by their own existence this problem. They're helping to solve problems when application is built from the development teams and then pushed to the operational team to be pushed in productions. This is not a solution, but it helps a lot in fixing this kind of behaviors. In a funny way, we can see containers as the box that you use when you go to the grocery and buy your cakes and let's say everything that you want to eat, or the boxes where your car is packed when you're buying a new one. So in other words, a cake is your application and the box is the container where the application runs. And speaking for a mechanic, your car is the application and the box is the container. Okay? Again, we'll try to push these ideas around cakes and cars, but I really aim to make it as simple as I can so that we can all understand what containers really are and how we can use them in our day-to-day life. For who? Obviously, DevOps. Development teams and operational teams. They use the same technology, they use the same methods. Images and container built by the development teams can be used by the operational teams when they manage the production system, and the opposite is true. If the ops teams build some images that the developers want to use, they can use them the same way. There's no, oh, I'm sorry, I'm just using this programming language. I don't know this programming language, so I'm sorry, I can't help you. They are both using the same tool, the same methods, and the same rules. And that's really why Docker is a catalyst in the DevOps culture. But containers are also used when the company you're buying your car from is building it, is let's say packing wheels and chairs and so on and so forth, but also in groceries when you're buying cakes and let's say, I don't know, some, like this one, for example. This little cake has been made probably using containers to run all the machines that is needed to make it. Containers are, as I said, almost everywhere. In our day-to-day life, we see containers in smart TVs, in ovens, in cars, but also in almost all the applications that we run in our web browsers. Your Google Mail, Office, 365, so on and so forth. Almost all web applications that we use in our own browser behind uses containers. I've made a few weeks ago a French recording around a Microsoft program, which is questions for developers. And the subject was what containers are for, and I've tried also, I'm sorry, in French, to answer that question using other use cases. Just feel free to reach out and look at this video. And again, if you have any questions, just drop me a line. Now that we've seen what briefly containers are, where they came from, and the use cases, let's think about, okay, since the year 2000s, we used to use virtual machines, and virtual machines were what everybody wanted to use in their own infrastructure to manage their application, to manage the development environment, and so forth. And when containers were born, or let's say made simply usable, we start to think about, okay, now I have two different technologies that address somehow the same area. So what are pros and cons between both of them? A quick summary in where we came from and where we are today. So first, let's say in the year 1990s, we were used to have a simple server with its own operation system, with libraries and the applications. We want to upgrade the application, we have to shut down the service to upgrade the operating system, to upgrade the libraries, and then upgrade the applications. And the year 2000, what virtual machines offers is an abstraction that packs a guest operating system with its own libraries and these own applications. So I'm separating and I'm, let's say, splitting into boxes my applications with its own libraries, but again, with its own operating system. And that's the first step into making easier to install, to deploy, to upgrade, to probably make rollbacks if there's any issues. And what we've seen coming as usable by everyone in our own area are containers. And what containers made simple is, okay, what we really need is the application and its own libraries. We don't need to bother with another guest operating system that takes time to build, that takes time to run, and so on and so forth. And that's that's exactly what containers are. Containers are simply an application and its own dependencies, and that's all. What we need to run that is a container engine that lives in its own operating system. So you don't have to bother about an operating system, its own hypervisor, and then virtual machine that has their own operating system, and so on and so forth. You have a simple physical server, you have its own operating system using container engine, and on top of that, you run applications. Obviously, if you have less, let's say, guest operating systems, probably you can consolidate more in the resources that you have available on your physical machine. But it's simply, that's exactly the same when you buy cakes. At first, you want to buy big cakes with fruits and chocolates and so on and so forth, and creams. But at the same time, you want to split it. Probably you just want to eat only fruits, not the cream, not the chocolate, and so on and so forth. So we start by making things a little bit smaller. We make smaller cakes with just fruits, with just chocolates, and with just creams, and making things easier to pack and to move. We're making even smaller cakes, and by making smaller cakes, they are also easier to grab, faster to eat. Also, sorry. But that's the truth. I mean, eating small cakes is too easy, and you just want to eat more. But that's the way. I mean, and that's exactly what containers are. Speaking to a quick. What offer virtual machines regarding the, let's say, the very old legacy and simple physical machine with its own operating system is a way to have more. As you are splitting your application with its own environment, you can then leverage more application in the same system. If you want to make upgrades, you're just operating the virtual machine that you're working on, but not the others. There are some cons. The first one is each virtual machine runs its own operating system, so it locks, let's say, a bunch of resources, and those resources are locked. Even if they are not used, they are locked. So let's say that they are not lost, but not available for something else. Again, a virtual machine is a full operating system with your application. Beware of the live system support, because you will have to maintain all the operating system that lives in all the virtual machine that you have deployed. The more virtual machine that you deploy, the harder it could become to manage all those guest operating systems. And the last point, probably the bigger one here, is as your application is, let's say, tightly coupled to its own guest operating system, moving the application means moving the whole virtual machines. And at some point, virtual machines as they simulate, let's say, the physical hardware. There are some cases in where you are not able to move a virtual machine to a shiny, new, and highly modern new physical server. That's where it breaks in ages. Speaking about containers now, what containers offer? Obviously, we dropped the operating system. As we drop the guest operating systems, containers are way lighter. And as they're lighter, they run faster. As a quick example, container runs between, let's say, 3 to 10 seconds. So it takes 3 to 10 seconds to run a container. As for virtual machines, we're speaking about minutes. So we're more about 3 to 10 to 15 minutes. This is way slower. Speaking about cloud, about scalability, about resiliency, needing more than a minute to run your application can be really troublesome. And that's where container helps also. As they are smaller and as they have a very small footprints, you are also able to put more on the same machine. They're just using resources needed by the application itself, not its operating system, speaking for virtual machines. Less resources, more resources available, and more container can run on the same machine. Of course, there are cons. And probably one of the most challenging one is about security. Most people tend to think, okay, I have a single operating system with a container runtime, and I have all my application that runs in the same operating system. So does that mean that containers are less secure than virtual machines? Obviously not. They are definitely not less secure. Let's say that the security model is completely different. What virtual machines helps in is virtual machines are completely locked between each other. Speak about concrete walls between rooms in your houses. Concrete walls will live between virtual machines, as the opposite as the walls that we have between our rooms are more of the separation between containers. They are not less secure, just the security model is different. And somehow people are frightened to use them because they're used to have something like very strong and very large and very hard to break. Again, as containers doesn't have an operating system and they just run your application, they are what we call ephemeral by design. Containers are made to start and to stop safely. And that's okay. I mean, containers are really designed to be stopped and moved safely. That puts a, let's say, kind of a an issue speaking about data that the application generates. Speaking about especially databases, because when you push your database schema into your MySQL, PostgreSQL, or Microsoft SQL Server, you don't want this schema to be dropped when your application stops. You want this schema to live where it has to live and be able to be used by another instance of your applications, of your database engine. And that's where containers starts to be a little bit more tricky in a way that you have to take into account persistency of the data that your application generates and manages, and you have to really, really make sure that if the application stops and the container disappears, data that it has managed or has generated doesn't disappear as well. That are, let's say, the simple cons that we can find in between. I probably haven't said that at first, but if you have any question, just drop them in the chat box. In between, I'll just make a simple post to see what would be the questions that you have, and I'll try to answer them probably before moving to demos and examples. Okay. So Which one wins? Actually, none. Neither containers, neither virtual machine wins. They are both great at what they are best for. As an example, I've worked with a client project which runs real-time and streaming data processing applications. And these applications should not be stopped by not any second. By the time that the application stops, the stream is broken, and if the stream is broken, there's no buffering somewhere in the system, so data lost. In this case, virtual machines are, in a very personal point of view, the best use case, especially because some features that offer virtual machines, often proprietary, I'm sorry, offer some, let's say to put it simply, in-memory synchronization technology. So what they do is they synchronize memory footprints of a virtual machines into different physical servers in the cluster, so that if the virtual machine dies, the memory that lives, the data that lives in the memory won't disappear and will be used by another instances that just fire up, let's say 1 or 2 seconds later on. Again, this is very useful, especially in this typical use case. And most of the time, these features are proprietary and probably will ask you to pay to use them. As an opposite, if your application is completely switchable, you can shut down an instance and fire up 10 more. You need scalability, you need a high frequency update processes, you need resiliency. That's where containers are best at. Smaller, lighter, faster to run, easier to move, and way easier to grow the number of instances that you may need at once. I mean, I'll show you that probably later on, but it's very easy, even in your machine, your own local machine, it's very easy to grow your container instances at once. You don't have to spin up several virtual machines and just wait for them to be available. You just have to fire up a very simple command and then boom, you're just switching to 10 to, let's say, 20, 30, 50, 100 instances at once. As a bonus point, I've spoken about that later a few minutes ago. We're starting to see some offering that tends to offer the best of both worlds. That's what VMware is working on with its own latest release. Red Hat with OpenShift has the same behavior, and there's a lot of other, let's say, vendors, either open source or proprietary vendors that tends to offer containers that runs on top of virtual machines. And in some use cases, this is probably the, how would I say, the almighty solution. But as it's the almighty solution, it also adds way more complexity, because you will have to manage virtual machines lifecycle and container lifecycle, which are completely different. Best of both worlds, yes, but let's look at it as a double-edged sword. That's the idea that I have in mind, speaking about containers on top of virtual machines. This is really a double-edged sword. It's very easy to use, and it can help you a lot in your fights and so on and so forth, but at some point, it could be tricky to use. Now, let's start thinking about what really these containers or these images, Docker images, or simply images are, how we can create them, and what we are starting from as a playground to, in the end, having your application that can run in its own container. Analysis, cooking, or mechanics depends on which suits you best. Let's see how it goes. So, as a first warm-up, just have in mind that A virtual machine is created from an ISO an installable image or a template. And this is clearly a read-only, like CDs that we are used to buy years ago to listen to our favorite musics. That's exactly the same. We're just spinning up ISOs or templates to create the virtual machine or virtual machines that we need. Containers are slightly different. They came from an already installed read-only image, and that's what we're calling them Docker images, or let's put it simply, images. Your container images or Docker images has the application already installed as a read-only file system, installed, not running. And what we will see is how we can leverage this, let's say, read-only device to run your applications. Docker containers, as I said, these images only host or should host only the application and its own dependencies and nothing else. Every shiny tools that we used to use in virtual machines, like process listing, like command line editor, TCP dump, and whatever the shiny tools, ZSH with the shiny coloration and so on and so forth. All of those tools doesn't have to be embedded in your production image. You don't have to use them in production. They can be used in the development world, yes, to do some debugging and to help you, let's say, be at ease when you're running them, but they are not necessary for your application, so they should not be embedded in the production image. And as we are using those CDs, ISO templates, those images are bid from a recipe. This is called the Dockerfile. This is its default name, and I'll show you right after that how we can use them. But to summarize this, let's have in mind that virtual machines came from ISOs and templates, and containers come from an already instance of your application into a read-only device that we're calling an image. Okay. To put it differently, when we're used to use those images, this images is around an application that you probably have already used in macOS or in Windows or in Linux. It behaves exactly the same. You're just choosing which one you want to use as the source of your upcoming virtual machines, either an installation device, USB keys, you're just copying the system and so on and so forth. That's how we are used to create our own virtual machines. Speaking about containers now, and speaking about cakes, layer cake actually in our case, we're just having our own ingredients, everything that we need to make our favorite cakes and its own recipe. So if you're a cook and you want to discover what containers are, you're just using the same. You used to make cakes using ingredients and recipes. Containers and images are exactly the same. Your ingredients is your application and its own dependencies and libraries. And your cake recipe is the Docker files. Using them, you're now able to create your very first image as you've learned to create your very first cake. That's exactly the same. How is it working? We have this recipe, the Docker file, that have different instructions. I'll show you that afterward. We're just giving this recipe to a build engine, a process that has been developed to create those images. And this builder reads your recipe and simply follow the instruction, and that's it. It reads the recipe, follow the instruction, and in the end, you will have your Docker images. As simple as that. The example that you have here is for PostgreSQL. So this is the official Docker file. I probably haven't told you about it, and probably you already know about it, but Docker, the company, has created a lot of already existing official images. There are images for most of the application that or languages that we are used to use: PostgreSQL, MySQL, WordPress, Joomla, Ghost, your favorite content management system, and whatever. And again, as this is an open source technology, you have the ability to create your own. We'll see that. So this example here shows you every instructions from this recipe that this builder will run and execute to create your image. What you have on the left in green are what trigger this builder. Each and any of them tells the builder to do something. Run is simply do this. User is be yourself as. Expose is open this network port. Volume is more about sharing data. And command is what do you have to run when you run this container. This is your recipe, the same as a cake. And this builder is your cook. And for this cook to make your favorite cake, it reads the recipe, exactly the same. Recipe, ingredients, Dockerfile. Cook, Docker builder. Docker image, your box with your favorite cake. And that's it. You just discover what containers are and what image are and how you can create your own. The rest is only about reading the official documentation, learning how to create your images. And that's it. There's nothing more complicated either than that. Recipe, ingredients, cook, builder, box, image. And that's it. If you're a mechanic, this is an example. When you want to create your own car or you want to fix your car, you also have some rules that you have to follow, changing route to changing wheels, batteries, and different components. And that's the same, but in this case, you are the cook, you are the builder, you are the mechanic. You're following the rules and you're making or fixing the car. The car is the Docker image that hosts your application. The recipe is the rules that you have to follow, and you are the cook or the mechanics. Exactly the same. So now, we just learned what containers are, where they came from, how we can make our own. And as I said, this technology has been created, evolved to be used by each and any IT teams in your own company or your own personal projects. And probably at some point you want to share them. You want to share the images that you've built. You want to share the skills that you've grown into learning how you can create your own Docker image and run your own application. And probably you now have these questions. How do I share my image? How do I run my applications? Okay, let's try by answering them one by one, again, simply, and see how we can leverage our cooking or our mechanics experience at the same time. So how do I share my image? A Docker image, when it has been built on your own machine, only exists in your own machine. There are different commands that you can use. You can export this image as a tar archive that you can put in USB key and then just give this USB key to whoever you want, but that's not, let's say that this is not easy. You have to create your image, do an export, push this image into a USB key, and then push and give this USB key to somewhere else. We have different catalogs, private registries, or public registries that are made available so that we can push our favorite images into them. These registries act as a huge catalog of Docker images for almost anything, any development language, any libraries that you may need, every application that you are used to use as a content management system, database server, web servers, caching systems, processing systems, machine learning, data lakes, and so on and so forth. Almost everything has nowadays its own Docker images, either built by companies like Docker and that has been optimized and secularized, or built by the community itself, myself, and obviously, hopefully, yourself pretty soon. If you are making your own application and you want to share it to anybody in the world, the easiest way is to leverage containers. Just create your own Docker image. Push this Docker image to the hub, for example, or any other registry that you are discovering and want to use, and just make this image available to anybody else, and that's it. You're sharing the knowledge that you've grown, you're sharing the application that you build, and probably at some point, somebody else want to contribute to your application and will also use this image to be able to contribute to your projects. There's a lot of, how could I say, to put it simply, open source projects that lives on GitHub that doesn't have either Docker files or instructions to create an image to leverage these applications. And I highly encourage each and any of you starting to learn what containers are, how we can create our own to help those projects. From time to time, I'm trying to help some of them into fixing bits and pieces, or just writing a few instructions into how they can easily create them. And I'm really, really convinced that by the end of this webinar, starting by learning what containers are and playing with them, you will too be able to contribute to those projects. This image lives on your computer, but you have to push. Push is make this image available somewhere centrally, the hub, Quay, and any cloud provider public registry available. And anybody else who want to use your image will pull this image from the registry. Push is make available, and pull is use it, simply. As for a cake, I mean, making cakes, and if you want to offer them or sell them, you're making cakes, putting them into a box or boxes, and you just make them available in the grocery. And in those registries, it happens exactly the same as in your favorite grocery. By the time that you are just pulling or buying your favorite cake, another one will appear. So there's no, oh, I'm sorry, I just pulled the image, so the image is not available. The image is always available. Either you're pushing once or twice, anybody else in the world can leverage it. How do I run my application? I love cakes, and I love lay cakes. If lay cake is my application, what I want to do is eat it, and that's it. If you're a mechanic, let's say that run your application would be more than start the engine and probably doing some race with friends. I'm not a mechanic, I'm more into cakes. So obviously I wanna eat my cake, and if my application is a cake, running my application is eating my own cake. And that's it. Let's make a quick pause. We are way above the schedule. We have time. Let's take a few minutes. If you have any questions, just please drop them in the chat box. And let's take, let's say, around 5 minutes to switch to the chat box, probably answer a few questions, and then I'll switch to some examples. Okay? So what do we have? Oh, no questions. Wow. So am I crystal clear? Seriously? No questions? Come on. Do you have any questions? Have you understood what containers are and how they're working? Someone said, crystal clear explanations, man. Thank you. Thank you very much. All right. So if there's no question at this point, let's switch to some demos and take some time to discover what containers are technically are and how we use them, right? So I'll just switch to another screen and switch to some demos. Let's see.
You have a question.
Oh, I have a question.
Sorry, a last minute one, yes.
All right, so how do you, for example, specify the port of a web app inside a Docker container? This is exactly what I'm going to show you. So hang on tight and you'll discover how it works. All right, so this is a simple machine that I've built in my favorite cloud provider. And I've prepared few very simple demos. All right, so we have Ghost, which is a blogging or a content manager, a very simple content management system. We have Nextcloud, which is more about an all-in-one solution with email, drives, or drive likes, calendars, and so on and so forth. We have WordPress. I don't have to tell you what WordPress is, or if you don't know what WordPress is, this is a very simple content management system, widely used nowadays, very, very widely used. And least but not last, we have PostgreSQL, which is a very famous database engine that is oftenly used as, let's say, as an alternative to switch from, to put it simply, to switch from database engine like Oracle to an open source database engine. Okay. So before starting to demos, there's one point I want to make very clear. Containers allows you to run multiple applications at the same time wherever this application or those pieces of your application lives. As we are packaging your application into an image, you have the ability to have different versions of the same image that lives in your cluster, in your cloud system, and so on and so forth. And that's what helps into upgrading your application from version 2 to version 3 and so on and so forth, or in case of any issues, to do a very fast, almost lightning rollback. I'll start by this Ghost application. So Ghost exists as a Docker image in different flavor, but also through different major versions and, let's say, minor versions. Obviously, version 2 or version 3, you see that in my screen, in my shared screen. Okay. So let's try by pulling this Ghost image. So what I'm doing here in this command is I'm using the Docker CLI that, let's say, connects to this Docker server that lives locally and ask this Docker server to pull. So grab an existing image or an probably existing image at this time. His name is Ghost and its version is 2.38.0. Let's see if this version really exists and how this Docker engine behaves. So we're just downloading a few things, extracting, pull complete, and boom, there we are. And at the last time it say, downloaded new image for Docker 2.13.0. Okay, if you look at those steps are exactly each let's say, green instructions that I've showed you before in the recipe. Each of those green instructions that you've seen before in the recipe are somehow these steps. I have chosen the layer cake for a very specific reasons. Docker images has been designed as layer cakes, exactly the same. All of those stages that you've seen here are exactly as the layer cake that you want to eat, exactly the same. And they are just piling up somehow, one on top of another, following the recipe, and that's it. So now that I have my image, I want to run it. All right, let's try something very simple as Docker, whoopsie. Let's say Docker run -d, because I want to have the prompt back. If I don't use the -d, let me show you what happens. So the application starts and seems to be running perfectly, which is cool, actually. But I don't have my shell back. The application runs in the front and not in the background. And that's where this -d option is for, to make this container that runs your application in the background so that you are able to trigger whatever you want to use. So let's start again. Control C, goes as shutdown. Your SID is now offline. Okay, and demo. I'm broke. Sometimes it happens. Okay, back. So let's see how it behaves with the -d. I just have this very strange string. I don't know what it is at that time, but I can use another option, which is a PS, which is like the Linux PS that just lists what runs, in this case, as a container. And I have several of them already running in this case. This is where my ghost instance lives. I said earlier that I have the ability to run as many of them as I want. Let's try. 1, 3, 4, 5, 6, 7, 8, 9, 10. And as you can see, the system currently behaves. I can go anywhere I want. I can go some top. I can do some messages. I can do other Docker PS. Everything runs. And as you can see here, I have all my instances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're all running at the same time. Now let's try by running another version of this application at the same time. So what I'll do is pull another version of this image, at this point the 3.16.0, and again, I have my layer cakes, same as before, pulling. The image seems to be running now. Let's try to run this new version and see if I can run them, both of them, side to side at the same time. Again with the -d, Docker PS, and boom, there we are. And it runs. Nobody told me, oh, I'm sorry, you're just running the exact same application once, so you're not able to run it again. You already have an existing instance of this application, so you can't run another one at the same time. And I can do the same. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do some PS, and it runs. If I want to switch to the old version to the new version, probably I would want to switch them off, those versions, the 2.38.0. And that's it. I can have the same application with different version working at the same time. This is often used into a deployment workflow that is called the blue-green deployment. We're having the version 1 running in production. We are making the version 2 live, but not in a production stage. And at some point, we're just running tests in the version 2. As long as those tests are all green, then at that time, we're just pulling back the link to the version 1 to the version 2. They are both running at the same time on the system. There's only one in production live. And once we're just ready to move to the next version, we're just pulling back the string just to get it to the new version, and that's it. Both are running at the same time without any conflicts into libraries and so on and so forth. I made a, actually, I think it was my first or my second talk in English in 2017. At DockerCon EU in Copenhagen. This is available on YouTube. I just shared an experience when I was just learning what containers are and how I can leverage them into a shiny new monitoring system. And I also show all the bad things that I've done with my teams and how what we seen at that time as, oh, containers are very cool, they're working, this is perfect, wow, now guys, let's go into production, just blew up in 10 seconds in productions. Look at it and probably, and hopefully you learn what I did wrong so that you won't do it again in your own project. Okay? What we're seeing now is pulling an already existing images. So now how about building your own? Let's look at what we have available here and let's look at this directory. Let's say version 3, what do we have? Oh, we have 2 files, and guess what? We have a Dockerfile 1. So what is this for? Do you see those orange instruction in this case? This is exactly all the instructions that the Docker builder will read and execute. And as I said, each, or let's say most of them, of those instructions, create a layer. Your Docker image is a layer cake, my favorite cake actually. And most of those instructions, to put it simply, generates a layer that has been put on top of another. So this example here tells to the Docker engine how to create a perfectly running Ghost version 3, in this case, running image. We have different instructions. If you want to learn more about those instructions and how to leverage them, I'll be more than happy to share some documentation, and probably help you into use them. As I said, I'm offering training, so probably you would be interested in, and just let me know. But let's say that those instructions are read by this builder. All those instructions are followed exactly by this builder, and in the end, we have the this Docker image. And now how to build it? The same as before, Docker build, specifying a tag here. A tag is a name and let's say a string separated by 2 points in this time. So let's say, let's call it Malt Ghost v1.0. And the last argument defines the context. The context is tells to this Docker engine, this builder, where it will retrieve sources or the sources of your application to create this final image. In this case, this is the current directory, so I'm just going to add point. Let's try it out. And as you can see, it's doing a lot of things. it could take some time in building your images. If a Docker container runs in 3, let's say, to 10 seconds, that doesn't mean that building these images takes the same time. It is okay to have, let's say, issues in this case. It is okay to have your builder needing few minutes to build this image and then this image to run in only a few seconds. Seems that I have a network issue here. So what's going on? Let's say, okay, I'll have network. I'll have resolution. We have something we call in French, dans le doute, reboot, which somehow says, if you have any doubts of what's going on, just restart the service. Honestly, I don't know what's going on, so I'm going to follow this French sentence and just restart the engine and see how it goes. This is how demos behaves. Restart Docker. Okay, let's do some status. Okay, seems to be running. And let's do it again. See, if you have any doubt, restart. Honestly, I don't know how to say it in English, but this is exactly what we tend to say in French is if you have any doubt in what's going on, just restart the service and probably it will work. And that's what happened. I just restarted the Docker engine and it works. So let's wait for this image to be built. And let's see if I'm available to start this instance, again, aside of all the others at the same time and see how it behaves, all right? By the time this is building, let's look at questions. We have 2 questions by Salah, actually. What requires from technical skills to use these containers on Docker? And can you zoom in? Oh, probably you're not, you have the option to put it on full screen, and this should allow you to see bigger what I have, actually. And if you have any issues, just let me know and I'll see what I can do on my end. But regarding technical skills, if, how could I say that simply? If you understood what containers are and how they are running and how you can create them, what you are missing is simply experimentation and learning and reading the documentation. Again, myself and others, we are offering, let's say, more complete training into helping you to exactly learn how to use them. But if you're not into having your company, let's say, contracting this training with myself or any of my coworkers, then what you just have to do is experiment and learn. And the official documentation is a very good starting point into learning what are those instructions, how to use them, what would be the correct order to use them, and so on and so forth. We have a funny way in the chat. Someone says, we don't have a say here in Mexico. We just restart whatever is failing. Yes, that's exactly the same. All right, so I'll build my image. So if I'm doing a Docker image ls to list, I have this image here, as you can see. Malt Ghost version 1.0 built a minute ago, and let's start to run it. Docker run. -d malt ghost v1.0, and let's see how it goes. Okay, what's going on? Let's take, oh, we have time, this is cool. Let's take 2 minutes, look at the screen and see if somebody can find what's going on here and what makes this image not able to run the application. You have two files. You have this docker -entry.sh, and you have this Dockerfile here, and there's something missing here. And that's exactly why my application is not starting. Is there anybody seeing what's wrong in the chat, perhaps? Come on, I know some people here, I don't want to name them. Yes, exactly. Execute permission on the screen, on the script. That's exactly it. This file here doesn't have the X bit. So as I used in my Docker file as a command in the end, as you can see here, to execute this file, if it doesn't have the X bit, then it won't work. An easy fix is chmod +X. There we go. And let me show you now what happens if I try to recreate the same file with the same name. Way faster because everything has been run before by the builder, and I only have changed the final instruction in the recipe. So in this case, it just leveraged what has been created before and just changed the last bit of instruction. Let's try it again. And since, there we go. Let's see. Docker PS. And boom, there we are. If you look at this screen, probably you have another question. If you remember before, I have 20 instances of an application that named Ghost that were running, and now they're not. The real answer here is simply because I've restarted the Docker engine here, and all the applications that are not managed by an orchestration system are simply shut down. And all those instances of this Ghost version 2, version 3 were just simply shut down. So I only have one here, but I can do the same again. So let's do Ghost 3.16.0, and let's say 2.38.0. I have all these instances and application that runs at the same time. And I can do it the same. So now we've seen how we can create an image, run an image, and run the application in this image. We've seen how we can run several instances of the same image at once and several instances of different versions of this image at once. But we are running on our own machine, and as you've seen, by the time that I have restarted the Docker engine, all those instances were simply shut down. And that's not what I want it to behave in production. I want it to be able to restart automatically at some point. Let's switch back to the slides and learn about a little bit more about how we can now leverage different behaviors to make those containers running. And again, if you have any questions, just drop them in the chat and I'll be more than happy to answer them. So let's get back to these slides here. So as I said, there's more. We've learned how to run our own Docker images and run our containers, but we don't know exactly how to easily expose them publicly so that this application can be used to anybody else. And we don't have at this time a way to easily scale or manage these applications. So let's see how it behaves. So microservices, orchestration, microservices. So Wikipedia says, microservice is a technique that arranges an application as a collection of loosely coupled services. In a microservices architecture, services are fine-grained and the protocols are lightweight. In a nutshell, building blocks. We were all kids, and probably most of us played with Legos and other building block tools. That's what those microservices are. Building blocks connected all together to, let's say, answer a purpose. As an example, in the playground or in cars, what we have here is a car microservices oriented application that has been broken in pieces. So we have databases, we have front end, we have back ends, we probably have caches and so on and so forth. And all of them connected together and picked up in the right way will make this funny car able to move. That's exactly it. Microservices are like in our playground when we want to build some small houses with windows, doors, stairways, and so on and so forth. And in this case, what we have here is a very simple example of what microservices can be. A toy, a car that has been broken into pieces, and all of those pieces are a microservice instance that connected together will make your application running and live. Probably you're seeing where I'm heading, speaking about cakes. So this is wedding cakes. We all have tasted one. We know how it is made. This is the same. I mean, we have the front end, which is the cream that we have in the front. We have the database that could be cakes that are put on top of each other, and probably the back end could be this chocolate cream that makes all of those pieces, let's say, stay put all together. This is a wedding cake, but a wedding cake is not a simple cake. This is different cakes that has been put on top of each other, smaller and smaller and smaller, with cream, with small cakes, and with a very small and shiny and funny couple on the top that represents the married ones. And that's the same. That's your microservices application seen by Cook. That's exactly it. To put it differently, these microservices can run all together, but they have to be managed in the way that probably we want several instances of databases, we probably want several instances on front end, and so on and so forth. Because even if your application is built on top of microservices, at some point, all of those services would need different instances of any of them to, let's say, to handle the queries or the browsing or the usage and so on and so forth. And in this case, that's where the orchestration systems comes to help. What we have here is an orchestra. Your orchestration system is simply the chief, in our case, the very famous Kubernetes orchestration system. And all of those musicians are the Docker servers that reads recipes and that, in this case, makes the melody so enjoyable. And that's it. That's an example of an orchestration system. Musician, chief, Kubernetes, Docker server. And that's it. There's no very complicated ways into building some tightly deep and very complex connections. Those connections exist, but to make it simple, Kubernetes and an orchestration system is just a chief and its musicians. The chief is Kubernetes, musicians is Docker servers, and that's it. Speaking about the cook, you probably have seen, well, in France, we have what we call cauchemar en cuisine, and we have a very famous French chief called Philippe Etchebest, which has won a lot of how can I say, distinctions in the cooking world, and for the English people, probably you know Gordon Ramsay, which was the first at running this this TV show, which is exactly the same as Cauchemar en Cuisine in France. And what we have here is Gordon Ramsay as Kubernetes, as the chief, and all the members of his teams are Docker servers. That's another way as a cook to see what an orchestration works. Chief cook, cooks, all working together to make what you want to eat in a restaurant tasty, very good, very well made. In our world, that's the same. You need Kubernetes, you may need Docker servers so that this microservices-oriented application that is built can run safely in this container world. And that's it, nothing else. Let's finish before the question session by a very, very simple example of orchestration. I'm going to switch back to the shell and just show you a very simple example with a famous known applications, and then we'll switch back to the final questions because I'm pretty sure you have many of them. Let's go here. And let's go to my friend WordPress. To make it simply, Docker run your containers, and several containers can make your application runs because all of those containers run a microservice of your application: database, front-end, cache system, indexing system, back-end, front-end, and so on and so forth. Obviously, you don't want to do Docker run -d blah, 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 first image, Docker run -d blah, 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 second image, and so on and so forth. This is clearly not a production way to run your containers. So you would want to leverage something else easier to use that can simplify the way to start all those containers at once and make your application available. What we'll see here is a tool code called Compose, Docker Compose, built in Python at first, probably at some point, I hope actually, be rewritten in Go because of different reasons. That's not the case here. And this application reads another recipe, a YAML recipe. And the YAML recipe, we have different examples here. And this is another way to do those Docker run -d blah, 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 my image, and so on and so forth. We're specifying what we call services. Services are obviously those microservices that your application needs to run. In this case, we just need two of them, a MySQL database and the image that hosts, to put it simply, let's say WordPress and everything else that it may need. So we run database service, we run WordPress service, and each and every of them are running their own image. We have a MySQL image and we have a WordPress image. And someone asked before how we can expose an application that runs in a container publicly.
We have the answer here. We are using the instruction ports, and we're just specifying the, let's say, the public port outside of the machine and the container port. Public port is on the left and the container port is on the right. And that's it. In this case, you can easily expose your applications. We're also leveraging different options, restart options, which is always this options tells that this container instance will restart each time that it has been stopped, either safely or not. And we are leveraging, other options around environments. And these are global system environments that we expose to through the container to the application that are used to do different things. In this case, it will happen to creating the database schema, specifying the root password, and a MySQL user and password for the applications. And we're just having the same. This application, Docker Compose, is called as simple as that. And we have a lot of options. What's very fun in these applications is as long as it finds a file called docker-compose-YAML, you don't need to specify the file. It will load this file automatically and then run the instructions in this recipe. In this case, we're just doing some Docker Compose -d, same as before, and let's see what happens. It says WordPress _db_1, WordPress _WordPress is up to date. Why? Because they're already running. PS. What it says is there's one that is listening internally to 3306, and there's another one that runs and lives in the port 8000. So you might want to try something like, let me get this to you. 67, there we are. So I'm gonna put a link on the chat and let's try and see what you have. So http IP address 8000. If anybody in the chat can test this link and let us know what happens then. If this works, I don't have any demo issues, you should be able to see the default WordPress installation page. Anybody in the chat perhaps? Yes, no? All right, let's do this command line. I can't see the link. It has been posted. I see the home. Nice. Cool. If you see the home, then it's working. So what I've done is I've used this recipe here. And this recipe with this very simple command here made my application available. That's the first step into the orchestration world. This is clearly not something that you would want to use into production because of different points that we can discuss later on. But this is a first step. And what Kubernetes and all other let's say orchestration system like Docker Swarm, for example, leverages is exactly the same behavior. They are just, they run and they read a recipe, and by reading this recipe, they start your microservice-oriented applications and make them available live, and most of the time, let's say, recipients. I see it, perfect. This is it for today and for this webinar. as I said previously in the previous session in French, this webinar is deliberately, voluntarily focused into discovering what containers are. If you may be interested into going probably deeper on into this orchestration world or learn more about containers, feel free to reach me out. I'll share you my information later on, or through Clementine to, I don't know, another session, or so on and so forth. So let's switch to the questions and see if I can answer them. Okay, so what do we have? Can you show us a demo of how to use Kubernetes? Yes, I could. This is clearly not our goal here, but again, at a later time, if there's interest, we can see how I can create something into showing how this Kubernetes thing works. Definitely. Could you please explain what Kubernetes is? I think I have an idea, but I'm not sure. As I said, Kubernetes is more like the chief in the orchestra of the chief cook. Kubernetes itself is a microservices-oriented build application. This is an orchestration system that runs different services at once, and all of those services talks to each other to make sure that your application is always available in good shape, and let's say running 99% of the time. So think about Kubernetes as a master brain that knows exactly what's happening in each and any of those Docker servers as services, applications, and so on and so forth, and that knows exactly what to do or what to ask those Docker servers to do to make sure that your application is always live and running. I have a question about orchestration. Kubernetes orchestrate between Docker servers. Kubernetes talks to those Docker servers using APIs. And just to let you know, Kubernetes is also able to drive others, container runtime, and let's say other pieces of software, as long as it has what it takes to talk to those APIs. So what Kubernetes is doing is just, to put it simply, let's say firing up API calls to those container runtimes to give them orders to do things. Start container, stop container, move this container from here to here, create this volume storage, and so on and so forth. Is there orchestration between the containers? Between them, no. What I mean by that is containers themselves are just boxes that isolate instances of your applications. So there's no communication or APIs in between. Those containers are run by this container runtime, in our case Docker, but again there are others container runtime that exists, and all of those container runtimes receives and gives back information to this orchestration system, in our case Kubernetes, through APIs. Is there anything else? What I mean is that Kubernetes orchestrates also between containers of the same application. So yeah, as I said, no, there's no autonomous communication systems between those containers. Again, containers are boxes, and those boxes simply said, just isolate your application instances between each and any of them. That's simply it. Do we have any questions? Any other questions? We have a few more minutes to go. We're right on the schedule, so if you have any questions, fire them up. And you are saying, I'm working on a web application, using Django and React and Firebase. What could you suggest to use Docker in this case? Question by Salah. I'm not sure I'm getting what you're aiming at. If you can probably explain a little bit more. I'm not sure. So if you can just drop me a line in the chat box so that I can understand a little bit more what you're expecting, that I can answer that. Like a microservice. Okay, let's answer what I think the question is. So in this case, this application will run Django framework, which run its own services. You will have your React frontend and Firebase as probably a hosted instances in Google, for example. So what you will do by using Docker here is you will use already existing Django images to leverage them and adapt them to make your own images focused on your projects. You will probably create other images that will help you to build this front end using React and connect those different instances, if you need, to this Firebase service using API. So this is not Docker that will be connected to Firebase. Docker will run these microservices either locally or in a cluster, and those services will be able to reach out to your Firebase instance to do push notifications and so on and so forth. That's how you would leverage it. Thanks a million for participating into to this webinar. Again, if you have any questions, there we go. Here's my contact information. Reach out anytime you need, and let's make it a deal for today.
Perfect.
17, the mic is yours.
Okay, thank you. Me, it's okay. If you have any question concerning Malt, you can directly ask your question to community@malt.com. But it's here, malt.com. And just to let you know, for people who weren't there at the beginning of this Malt Academy, this is it was recorded. You can find every replay on the website maltacademy.com. So feel free to go and check every replays and future Malt Academy. And again, we are looking for speakers, so don't hesitate to complete the form on the website. If you have any talks, I will. It would be my pleasure to include you. And voilà, it's okay for me. No one has question. Okay. Okay.
I think it's fine for today. So.
Okay. Perfect. So, bye everyone. See you next Malt session. Bye Rachid. Thank you for everything.
Thank you very much.
Bye bye.
See you next time. Bye.
Bye.